So here is, I was recently gifted, I should say recently, it's been sitting here for like a year, gifted this bandsaw. The problem with it is I want to cut metal and it only cuts wood, and what I've tried doing was just putting a metal band on it, even though I know speeds and feeds, I am a machinist, but I thought maybe with the right tooth count I could get away with it, and it turns out it doesn't really work. So I started thinking about ways to slow it down and seeing what I could do. Oops, sorry about that. And sorry, my knees aren't so good. At first, what I concentrated on was redoing the pulleys, but that seemed like a whole big hassle, and I wasn't sure if the results would slow it down as fast as I would want. So then that led me to slowing down the motor. This is an AC motor, 120 volt. In the research I did into that, I found out that, you know, you could install like a rheostat or a light dimmer switch, and yes, you could technically slow the motor down, but you're also killing the torque of that motor. So my 1 1/4 horsepower motor would not equate out to 1 1/4 horsepower anymore. I mean, if I cut the speed by half, I cut the power by half. So that was a little less than desirable. And then I found out if you interrupt the frequency, for example, a house runs usually at 60 hertz. If you slow the frequency down, you slow the motor down without affecting the power. So what you need for that was called a variable frequency control, and those are a couple $100 if you can find one for a 120 volt system. So in order to do that, I would most likely have to spend about $200-300 on the controller, and then either swap out my motor for a DC or a single phase 240 volt motor, which would be more money. And that's a lot of money to put into a free, cheap bandsaw. So I was trying to figure out what I could maybe use, and I was running on my treadmill, and it dawned on me. A treadmill has variable speeds. It has an electric motor. It has a controller already on it. You can control the speed, and I picked up this beauty for the grand total price of absolutely free. Matter of fact, I think somebody paid $50 for it at one point, but I got it for free because it doesn't work. Now, by it doesn't work, the motor spins, however, the belt does not. And the guy said, well, I think you just need to replace the belt on the inside, and then you'll have a good treadmill again. And I didn't quite have the heart to tell him that, well, yeah, we're not doing that. I'm going to take it apart. So I'm going to take this apart. I got nothing into it, and see if I can use the parts from this on that, and how much fabrication's involved. This project could go well. Matter of fact, if you see it on YouTube, it probably went well, or it could not. So I'm not going to do the long exposed time lapses here. I'm just going to show you what I need to show you for whenever I tear it down, because I don't know, it doesn't seem my time lapse videos get a whole lot of praise. And somebody said recently I talk too much, so I'm going to shut up and I'm going to take this thing apart. So teardown has commenced. I have the whole top disassembled, that's disassembled. I fully believe the owner when he said it needs a belt, because the previous owner, because you see all those belt shavings in there, that belt was definitely slipping. But it is a 2.9 horsepower motor, so it's more than the 1 1/4 that's in there in that thing. Sorry for spinning you around, I gotta keep in mind not to do that. But I ran into a snag when I took this apart. Originally I was just going to take the electronics out of it and leave the rest, but what I found is that most of these buttons must be some sort of like I don't know what they call it, but you know, they're not actual buttons. I thought there would be a button underneath here, but there's not. It's like electronic tape, and this comes through to there, and I completely cut this out. So I just have to reattach that, and then maybe I'll have to put this whole thing, or at least, you know, lop it off like right there and right there, and leave that circuit board in there, and, you know, use that to control it. Because once the speed's set, I shouldn't have to adjust it much, so it could even leave or live underneath it. I don't have to have it on the outside. But we're still going to proceed with, I mean, with everything else stripped off it. I disconnected. I didn't throw anything away, but I disconnected the incline board that read all those sensors. That was some sort of a phone jack that I took out. There's an LED light that I disconnected right now, and the ports for your headphones and stuff. That's all I think I disconnected. But the nice thing about keeping it all together like that, though, too, is if I plug it in and it doesn't work, if nothing turns on, I can start plugging stuff back in to see what makes it tick. That's the controller. I believe that's the motherboard. Sorry, I keep spinning you guys. And that's the controller. That's the incline. I'm not going to need that, so I can leave all that. I'm going to try to save as much of that bracket as I can. But first things first, let's see if we can get it to run as is. I got to feed this wire right here back down through to there first, because that'll be like the test to see if everything works out of the box. And I got to pick up all those screws, because I just found out I'll probably need most of them again. That's another thing. Whenever you're disassembling something like this, don't just pitch all your screws, because you never know when you might need them again or when they might come in handy again. And actually, I think that's an adjustment. Wait, right there, that bolt. If you loosen that up, you might have been able to tighten that belt up and get it to work fine. But that's not what I'm after. Not after a working treadmill. I'm after a working saw. Alright, here we go. Alright, she's plugged in, stripped down, and I have to say, whoever fed that wire the whole way up through this arm and over to here, it's crazy. But I left everything I think I don't need disconnected. The incline's completely disconnected. I disconnected the motor for the incline. I disconnected the tack, so there's not going to be any real speed symbol, and honestly the tack is up on that pulley anyway, so if I was going to reuse it, it wouldn't work no matter how. If it was reading off the flywheel, I might try to keep it, but since it doesn't read off of anything, yeah, it's going away the dodo. Nothing to it but to do it. I left this hooked up. That's your emergency stop. Let's see if I burn it down or not. Ooh, it's working. Let's see if I can speed it up. We got maximum velocity. Coming back down. Alright, now to see if I can get that all mounted in the saw and how I'm going to do it. Now here's a look at the backside of my bandsaw, and realistically, as long as I can get the other motor to mount in here, the rest of it can kind of live down here somewhere. I might get a box or something and put it all in. Or some sort of a shelf to protect it from the dust and the dirt. But I mean, honestly, there's supposed to be like a vacuum system down here, but I don't have it, and I'm not looking to buy it. I could make a little tube to come off there to take the debris down to the floor so it doesn't get all over, because most of it actually gets captured in that plastic thing. Anyway, I'm rambling. I disconnected for the most part of this. I did take a picture of it before that, and it just basically hangs on with, and I'm sorry, oh, that's really bright. 4 bolts here, and here is your here is your adjustment to tighten it up. I've already loosened that up. When I loosen these bolts, this motor should go slack. come out, I'll take that screw out of there, drop this motor down, and then start measuring to see how I can fit the new motor up in there. The only real drawback, or the thing that might make this interesting, is that flywheel that's on the other electric motor. If that gets in the way, then this might get real interesting. And if I can't take it off, I haven't even looked at it yet. But I'm gonna get this one out and then get that motor out, and then lay the two side by side and see what measurements I can take. It's basically the same belt design. It's still a rib belt, and you know, it shouldn't be, the belt at least shouldn't be too complicated, but we'll see. Okay, so I got the motor off the treadmill, and like most treadmills, they need a lot of mass to keep running with all the load they have on them, so it has a pretty substantial flywheel on here. And that is connected to the rotor in the motor. See, as I spin this, I don't know if you can see that, but this little guy here spins. And it appears to be threaded on there. I have no way that I can think of holding on to this guy. He's got like a couple ears on him. Like, no, not really ears, like little indentations. There's probably a special wrench for this. But I have neither the time nor the resources to obtain such wrench. So we're going to try this in a bench vise and see, let me turn it, if I can unspin it from there. Now I know it might damage the end of this thing a little bit. Oh, we might need some heat or something. Yeah, it definitely looks threaded. It doesn't look like it's been pressed. But I need to get past the flywheel. You know, ooh, I hate to heat this up. Alright, we're going to try just a little bit of heat. So here's what I got, and it's not really good. It's not horrible, but it's not really good. So this is the motor out of the saw, 120 volt AC, 5/8 horsepower. It says like 1 1/4 on the thing, but I don't know if where they're measuring that, because it's a 5/8 horsepower motor. It says so right on it. But anyways, it is right at, let's say, 5 and roughly 1/8 inches from side to side. And, well, you guys can't see that. Yeah. There's a lot of flywheel in the way. So that flywheel has to be removed and or trimmed. Honestly, I don't think I need it. I mean, that one runs with just that. I mean, this one ain't going to be much different. Once the bandsaw is running, I mean, it might not even be a bad idea if it does stop, if it gets into a bind. Plus, it's a 2.9 horsepower versus a 5/8. Oh, 1 3/4 continuous duty. So, I'm at a crossroads. There's a machine shop up the road I could probably take this to and have them trim down. I don't have the means to do it here, mostly because I don't have a lathe. Like, this is balanced. You can see it's drilled back here. Well, you can't see it, but right there's a drilled hole. It's been balanced. So I can't just break out my torch and just hack it, because then it'll go and it'll vibrate itself to death. My query though is should I give it to him with the whole motor and have him trim the flywheel, or weld a nut on here and then flip this sucker around and see if I can twist it out that way. Or actually weld the nut on, put the nut, clamp it in a vise, and see if I can take it that way. And then the nut could live there forever as long as it ain't touching anything, and even if it is, it might self-clearance after a minute. But I don't want to damage any of the windings or anything in here. I could take these off and slide the whole armature, the stator up out, and leave the rotator. I don't know. I'm going to ponder this while I eat some lunch. So, if I learned anything over lunch, other than the fact that I like sausage and spaghetti at the same time, because leftovers, you know, is I watched a quick YouTube video. Supposedly this is a left-handed thread, so me turning it this way was only tightening it. So what I have to do is turn it, and it still doesn't come off. Oh, there it went. Ah, diggity. Smarter, not harder. How about that? Woo-hoo-hoo-hoo! That makes me very, 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 very happy. Yay. Alright, enough of that chitter chatter. I'm gonna figure out if I'm gonna put this pulley on here, or do like I said and use this one. I have an idea that I might put forth on getting this one, getting this flywheel off. But yay!
Hi, camera.
So I enlisted an assistant here, and what we're gonna do is we're gonna use my hole saw, and we're gonna attempt to cut, because it fits fairly decently down over that. Oop, fairly decently down over the center hub.
I just want to say something. Dad took apart a treadmill over there to do this, and I want that treadmill.
They know we have a treadmill. But anyway, slow speed. I probably won't film this all, but he's going to be squirtizing. Give me a little squirt in there, just a little squirt, a little more. There we go. And we're going to let that go for a little bit. Okay, I'll get back to you when I'm about through.
Okay.
No more time lapse.
My feet!
Okay, I added the C-clamp to hold it still because it was moving around too much. It just clamped to the bottom of the vise. But we're squirting along. Alright, we got that sucker out of there.
That was really quick.
Yeah, that only took a couple minutes. I'm actually kind of impressed.
Once we unpaused it and showed, the cutting part, whenever it wasn't all the way through, and we tried again, and then it went through.
Yep, and it's got a bit of a burr on it, and I'm real close to the edge here, so I don't think that it'll be very out of balance, if it's out of balance at all. And I think it'll work just perfect. And if worst come to worst, I'll take it to George. Worst come to worst, I'll take it to a machine shop and have him true it up some, but I don't think it'll make that big of a deal being that small. Okay, onward. So, I have, through the arduous process of cardboard aided design, came up with a design for a bracket. I'm going to make it out of steel. And this bracket has got this bolt pattern. For this motor, sorry, I'm looking at the camera. For this motor here, and it'll slide up and over the backside of this motor. I'm not going to do it right now, but that's why those notches are on there, so I could slide it all the way up tight against here. Now, here comes the tricky part, and I haven't quite figured this out yet. From here to this mounting surface is what is it? It's 3 inches. Wait, I have it written down. 2 inches 300 thousandths from here to here. And from this surface to this nut, which is what they used to mount against, it is 2 inches 600 thousandths. So there's 300 thousandths difference between this surface and this surface. Now, one of the things I can do is, because I'm mounting on the back side, is to take into account this thickness here, which is 75 thousandths, so about a 16th of an inch, maybe 80. I don't know. What's it say? Yeah, 75. 75. So that means that I've either got to offset this pulley out about 250 thousandths, about a quarter inch, or I got to move the backing plate back about 200 thousandths. I don't think a 30 seconds is going to make or break it. What I'm contemplating doing is to put something underneath here, make just a shim, so that way when it screws tight, because if you take this off and you get something like a washer that'll fit on this collar and then let it screw down onto that. I keep forgetting this is a left-hand thread. That could very well space it out. And that would honestly probably be the easiest solution. The other solution is to figure out how to move this plate back a little bit. I'm going to chew on this and I'll let you know when I come up with. So, my grinder's slowing down, but here's my bracket. I plasma torched and then filed and whittled it out. And the notches fit, how am I doing it this way? Fit over these two. So this is going to slide on through like such. And voila! Now I'm going to tack weld that. You know, 3 or 4 beefy tacks out to hold it. I don't have to get too crazy. It's not a whole bunch of torque on it. What the next step is to clamp this sucker up. Oops. And put a little zippity on it. Well, I gotta buff off a little rust, but you get the idea. And once that's done, I think I'm done for the night, and I'll pick this up tomorrow. Dinner time. Yeah. Alright. So, first off, don't be afraid to think, don't get caught in thinking traps. And a thinking trap is where you were thinking about a problem only in one direction. And I was really worried about that 300 thousandths that I was off and how I was going to fit for it, because the pulleys have to line up. So I was trying to take it out of the motor, but what I realized after a bit of a night of sleep is if you take this, and I may not be able to do it with one hand, but there's nothing holding this one but that keyway. And I can slide, if I have both of my hands, this one in and out pretty easily. So I'll probably take it from here, move it out roughly a quarter inch, maybe a little more, like, you know, what would it be, 5/16? And leave this guy right where it is. I'm so confident of it, I've Loctited it so it doesn't loosen anymore. And I tapped these studs in for the new motor. They're drilled, tapped, and Loctited. I got a little blue Loctite on every single one. And that's just so in case I have to switch this motor from running the way it's supposed to run to running in reverse, depending on which way it feeds the saw.
Yeah, that inside piece looks like the watch because it's red.
Yep.
If you look at it, whenever it spins, it's kind of like your watch.
Yeah, George is noticing the coils on the inside. He says they look like the color of my watch.
Yeah, they look red.
But everything still works. George is here to give me a hand. Now we got to get all the rest of everything out of that right there. Okay? You ready, George?
Me.
Alright, now you gotta strip out. We're gonna leave this attached to there. I haven't figured out too much about that yet, but we gotta take this out and get it mounted along with this power cord. We're gonna rob it, or at least rob what the plugs are to it, and get it all transferred over into our new saw motor. Alright. Good.
Bye. I just before, whenever we were doing work, we found this skateboard that was found in a building, and there is another skateboard. There is also a skateboard that Dad had. He just never got to use it whenever he was a kid. So I'm gonna learn how to skateboard. There's a skateboard that we found in a building that no one took. So we took it, and I like the bottom a lot. Bye.
Alright, so the most part, out of all that electrical stuff in there, the only things I kept was this circuit board, the control panel for now, we're going to play with that at another time, and the motor. Sorry, lost my train of thought for a second. I noticed this in the motor, and it slides into the tail end here in one of the and like a slot. There's like a slot here or a slot here, and they can go into either one. And at first I thought that it had something to do with the motor excitation, and I don't think that's true. It occurred to me because I was originally just going to eliminate and hardwire through this, but you notice how that says, it doesn't say off and on, it says off and reset. And that got me thinking, that may not exactly be a switch. I mean, yeah, you can turn it off and on here, but I was like, that doesn't seem to be just like a normal switch would just be off on. And then I looked at the board, and I'm not sure if you can see this, but this says CB1A, and then on this side it says CB2A. And that tells me that this is a circuit breaker. And I think what this does is it basically senses heat. Whenever it gets so hot, it trips, cuts the ground to the circuit breaker through the card, and I think that's a fancy thing to have. So we're going to keep that. Now, here's where I'm going to get into the tricky technical stuff. Okay, these are the leads that power the motor, and they connect here. Okay, black to black, red to red. I had them marked before I took them off, and they just plug back in. Okay, pretty self-explanatory. These are the leads that used to go to the old power cord. I don't want to get another power cord. I have a power cord here that powers a light and everything else on the saw. And the switch for the saw off and on, the emergency shut off, is up front. So I want to keep all that wired. So what I'm going to do is I'm going to use the wiring for the motor, the old motor wiring. And I'll probably end up putting like this ground screw somewhere. And then these two, well, I mean, I'll ground it to something. I might even attach it to the ground on the motor, I'm not sure. But these two here, positive, your common and your neutral, I'm just going to plug into here, which this is what the power cord plugged into. The power cord had the common, neutral, and then of course the ground out of the power cord just ran to a screw that tapped into the frame. kind of do the same thing, except this one is already grounded. I just want to make sure this stays grounded. You know what I mean? You can never have too many grounds. Unless you're shorted out, then you have way too many grounds. But it should just be all plug and play. Oh, and whenever I kick it on, if the motor spins backwards, like if the saw blade's teeth are not going in the correct orientation, correct direction, all you do is take this red and this black off, this red and this black off the motor, and flip them here, red to black, black to red, and then that'll reverse the polarity of the motor, make it spin the opposite direction. Doesn't hurt anything, just makes it spin backwards. Okay? Alright. Oh, and I just drilled and reused 2 screws to mount this circuit board up here. Alright, here's the hoping. Alright, I'm about to throw power to her. Let's see if we let out all the new smoke. Lights on. We got some powers. I think it's going right. Yeah, it's going the right way. Yeah. 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 Get you some of that. Alright, I think the final thing I might do is lop off the top of this and figure out some way I can, you know, hang it or something. Eventually, I'd like to do away with this and just put it like on a rotary dial somewhere. But, I mean, for right now, I'm sorry, I'm just a little impressed with myself at the moment. Let me stop it, put all this back together, and then I'll try to cut some metal. And this isn't a new blade, by the way. This might have been a blade that I might have ruined some. So if it doesn't cut perfectly, I might just still need a new blade. And make sure if you do this conversion, you get a metal cutting blade. Alright. Alright, just keep in mind, I've already kind of burned up this blade a little bit, but let's see if she cuts. Say it's really loud, you know, we can work with it. Probably need new blades again, but like, I don't have a problem with it. I don't know, I'm tickled pink with that. Alright, that's too much video. I'll have to edit some of it. But, yeah, done for now. Like I said, I'm just going to lop the top off this, hang it up, and that's how you turn your bandsaw from a wood cutting bandsaw to a metal cutting bandsaw with use of a treadmill. case anybody didn't believe me with this saw blade shot, this is it trying to cut wood. Struggling. Alright. So, to further finish it up, I thought I would wire in a potentiometer and get rid of this whole display. Why? Because I don't really need to know in mile per hour how fast I'm moving, how many calories I burnt, and the incline, the fan, and everything else just doesn't work. And then I'm going to have a simple knob to control my speed. But while this one is for a treadmill, it is not for this treadmill. This is a Pro form. I don't know what model you get. Some of them, they say just, oh yeah, all you gotta do is plug this into your card and you're done. Well, unfortunately, mine has this guy. So there's 1, 2, 3, 4, 5, 6, 7, and there's 9 wires on here, 2 of which are grounds. So what I did was I set my multimeter up to DC voltage, and what I was trying to find is there's going to be a send and a return. There's going to be a signal and a return, and a ground. Both blacks are grounds. Found that out. No problem. Whenever I disconnect it, I'll double check that whenever I disconnect this, that I don't lose a ground, just in case, I don't know, somehow it's grounded through here, back through there or something. I don't know. The second thing is I needed to figure out which one supplies the power and which one supplies the signal. All this is basically a giant resistor. Okay, and you're just changing the voltage across the terminals to tell the circuit board, to tell the motor what speed to go to. And what I found is, at rest, purple's at 3.4 volts, green's at 3.4 volts, orange is at 12.4, and both blacks are grounds. Then whenever I started it at 1 mile an hour, purple's 3.4, blue's 3.1, and then green goes to blue goes to 0.31. Blue wasn't there before, and green still stays at 3.14. Then when I increase it to 2 mile an hour, blue stays at 3.4. Purple stays at 3.4, green stays at 3.4, and then blue goes to 0.44. And at 3 mile an hour, everything stays the same, and blue goes to 0.55. So blue's my variable, and I think that either the purple or the green are my send, or the orange at 12.4. So that's going to be my next step, but I definitely know that blue is my control wire. And what I'm going to do, and I've already started it here, is none of these wires are next to each other. So I'm going to take this plug off and plug the ends in individually to see which ones work. And to do that, all you got to do to take these plugs off, and this is for most of your quick connects, is push the wire in just a little bit. I got to push it in with my hand. Push that little tab down that's on top. Oh, didn't push it down far enough. It's a little tricky, but now that I'm on camera, it's going to make a liar out of me. You push it in, push the tab down, there it goes, and it'll pull right out. Okay? Yep. And now I can rearrange these wires however I want. I believe black is in, black is ground, red is your input voltage, and white is your signal voltage. Or, excuse me, if you don't have the wires hooked up, your two outsides, one's a ground, one's power input, and then the center one coming out should be your control voltage wire. So this way I can hook it up, flip it around a bunch of times if I have to. If I cut the wires and just soldered this in, it would be permanent, and then I'd have to cut, splice, cut, splice, cut, splice to keep trying different combinations to see what works. And like I said, there's power going into this thing for other things too that don't really apply. So we'll see what we get. So after hours, and I do mean hours, of trying to figure out how to make a potentiometer work for this setup, for this ProForm Series treadmill, which is also manufactured by Norditrek, I found out that I have the wrong circuit board for it. This circuit board, because I couldn't figure out how to get around it, I unplugged it, plugged it back in, jumped a bunch of voltages around, and tried to test different voltages at different times. This circuit board here transforms the DC signal coming in into a pulse down the blue wire. So the voltage on the blue wire changes, but it's not reading the voltage, it's reading the pulse. And you can make a variable pulse box. I don't know how to do that. I don't have everything to do that, and I think that would kill some of the budget in our budget-minded treadmill thing. So if you get and do a little bit of homework, a little bit more than I did, well, I can't argue either. It was a free treadmill. I mean, it's still better than what it was. Like, the saw is still better than it was. There's no way that the saw is not better. It's got more power. It's got variable speed control. The only thing is I can't actually, like I thought in the beginning, I can't do away with this without, you know, spending some money and doing it. The only expense I had was I had to buy the screws to mount the motor. They were 1032 screws. I just didn't have any, and it was like $2. I did go to the expense of buying 2 potentiometers. They were $8 for 2 of them. I think for $8, that's not a bad lesson learned. Yeah. So what I'm gonna do now is I'm gonna clean all this mess up, turn the saw around, change the blade out to an actual metal cutting blade, and try it out. Alright. So I'm not completely cleaned up, but I can't help but show you guys. I got a good Starrett blade in here, and I know it should go without saying, and I misread when I ordered my last metal blade where it said what's the minimum thickness you'd be cutting, and I picked 1/4 to 1/2 inch when it turns out it was 1/4 and below, and I don't think I'm gonna be cutting much more thicker than 1/4 inch on here. So I got a better blade. It's actually a Starrett blade, but let's go ahead, power it on. Ba-boom. Alright, we came up to start, and from what I found just playing with it, it's at about 1 mile an hour now, but if I speed it down to 0.7, that seems to be the happy spot. And sucker powers right through a piece of steel. It's not shooting sparks like it was before when I just tried throwing a metal blade on it. I just really couldn't be happier with how this turned out, honestly. Like it just... Like, now that I know that, I'm probably going to order 2 or 3 more blades just to have on hand. Probably get rid of a bunch of them too. But, I mean, what more can you expect? Other than my fail with the potentiometer, I have literally $2 into this, and I have a metal and wood cutting bandsaw. All I gotta do to cut wood now is swap the blade out for a wood blade and crank the RPMs up a little bit. And it's completely variable. One day soon, maybe. Sorry. I'll show you how to get rid of that. I mean, it's just hanging here by the hook. Oh, you can't see the hook either. There you go. Just hanging here by the hook, and you know, you control the speed. Same as everything else. Like I said, there's switches the whole way across, and I don't want to mess with that. But for having, I mean, if I hadn't tried that potentiometer thing, I have literally $2 into it, and now that I have tried it, I learned a little something. Not all treadmills are built the same. This one has a pulse width motor, control motor, not a voltage control motor. And one of these days I'll get into figuring out how to create something to help control the pulse width. Till then, I'm Tickled Pink. This has been the GSE Shop, and Please like, comment, subscribe, whatever. And if you want to see more of this kind of stuff, let me know. Okay, out.